Let me now give you a problem to try involving a frequency distribution and converting it into a probability distribution and then finding some probabilities. So in this case, we have maybe for a particular neighborhood or whatever, the number of children, and this is the number of families or number of households that have this many children. So these are the frequencies. And so now a family is selected at random from the group. Let X equal the number of children in the family. And then it wants you to construct a probability distribution for X. And then it wants you to calculate each of these probabilities. So go ahead, press pause, give this a try, then you can start it back up and see how you did. Okay, so let's go ahead and see how you did here. I'm going to grab a sheet of paper here. So we're going to construct the probability distribution for X. These are the numbers 0 through 8. Okay, and so now to find the probabilities, what I'm going to do is I'm going to have to add up all of these. And when you do, you actually get 100. So the total frequency is 100. And so now for the probabilities, it's going to be each one of these divided by 100. So you got to make sure to put each one over 100. And if you add these up, these will indeed equal 100 over 100, which is a probability of 1. Okay? And I'm not going to worry about making the histogram. Let's just go ahead and find these probabilities. So I'm going to go ahead and write these down. So B was probability that X is equal to 2. C is the probability that X is equal to 7. D is the probability that X is greater than or equal to 4. And E is the probability that the family has at least one child. Okay, so these are the probabilities, and we have our probability distribution, so we should be able to find these. So what about the probability that X is equal to 2? So in this case, it's 24 over 100. And you can leave it like that. You could reduce it. I'll just, if I reduce it here, I could multiply top or divide top and bottom by 4. I'd get like 6 over 25. But it doesn't matter there. You could do a decimal if you wanted to. So now the probability that there's 7 children, well, you go to the table, none of the families had seven children, so it's 0 over 100, or just a probability of 0. So it's impossible. It's an impossible event. So what about greater than or equal to 4 children? So now you got to add these up. So this is 12, and that's 8, so that's 21 over 100. So 21 over 100. And I'll just leave it like that. And then probability of at least 1. Well, I can add all of these up if I wanted to. Or I could just subtract 1 minus. They all add up to 1. So just take 1 minus the probability that they have no children, which is 17 over 100. So this is like 100 over 100. So it's really 100 minus 17, which is like 83 over 100. That would be the probability of having no children.